Hi guys, Mr. Kane here. Just wanted to talk about some of the issues that I saw on Molecular Geometry Lab Part 1. There were some common mistakes. So here's my screen here. First common mistake that I saw was with H2S. With H2S, we've got two electrons from the hydrogen plus 6 more from the sulfur for a total of 8. Sulfur goes on the inside, hydrogen's on both sides, and then we got 2 bonds. I think that this was the cause of the most common misconception. A lot of people wrote linear for the orientation here. Can't be linear because the drawing was incomplete. If we add in all 8 of the valence electrons, we wind up seeing that this would be tetrahedral as far as the orientation is concerned, because there are 4 electron domains. There's the lone pair on the top, the lone pair on the bottom, the bonded pair on the left, and the bonded pair on the right. That's a total of 4 domains. Now, those 4 domains give us a geometry. Since 2 of them are bonded pairs and 2 of them are lone pairs, that gives us a geometry of bent. Since this is tetrahedral and bent, we're seeing that the angle of our bonds is less than 109 degrees, and since there's 2 lone pairs, it's much less than 109 degrees. If we're going to talk about the polarity of this molecule, the sulfur to hydrogen bond, check my periodic table here. The sulfur to hydrogen bond does show up as being a difference of 0.4. Hang on, I need to check my notes. And we decided that 0.40, we decided 0.40 was nonpolar, so this is a nonpolar molecule. All right, the second issue that I saw was with SO2, so I'm going to scroll down just a little bit. Looks like most of us did okay on NO3 and CO2, so nicely done. SO2, we've got 6 electrons plus 12 electrons. That's a total of 18. Sulfur goes in the middle, oxygen on either side. Now, I'm not sure where the misconception was coming from here. The misconception that was coming was that this is going to be a linear orientation. Again, I'm thinking maybe the Lewis structure wasn't completely drawn out. So we draw 2 bonded pairs. We put in some lone pairs. 2, 4, 6, 8, 10, 12, 14, 16. Here's 18 right there. And then the problem is that the sulfur doesn't have enough electrons yet. So I'm going to erase a pair of electrons off of this oxygen on the left side. I'm going to draw them in over here so that now I've got a double bond. So as we can see here, we've got an electron domain here, an electron domain here, and an electron domain here. So I've got 3 electron domains. 3 electron domains is going to give me a trig planar sort of orientation with bent as being my geometry. Since this is bent, we're going to be talking about since this is trig planar, we're going to be talking somewhere in the 120 degree range. Since it's bent, the bond angle is going to be less than 120 degrees. And as far as polarity is concerned, sulfur to oxygen is definitely a polar bond. And this is going to be a polar molecule as a result. PCl3 was the third and final misconception problem. I'm seeing for phosphorus 5 electrons plus 7 apiece for the chlorines. That's a total of 26. So phosphorus is going to go here. I'm going to put a chlorine, and a chlorine. And since we're getting so good at this, we kind of know that we can get away with putting lone pairs around 3 sides of each chlorine and we can draw a bond to the phosphorus. Now, those of us that are quick with math, we see that we see 3 sets of 8, so that's 24. 26 would be this. The misconception was trig planar here as far as the orientation, and I think that those people were missing these 2 lone pairs up here. So the shape is actually tetrahedral. Okay, forgive my spelling here. I'm trying to write and it's not just writing nicely. I guess that I could say that all 3 of these problems, the problem was forgetting about lone pairs. Remember that thing hanging in the ceiling in my classroom that's so lonely right now because no one's with it? It literally is the most lonely pair on the planet. Don't forget about it, okay? So because we got tetrahedral, we got 3 bonded pairs with 1 lone pair, that means that we're going to be doing something trig, and this will be a pyramid. Okay, trig pyramid. If this was a perfect tetrahedron, I would have expected 109 degrees, but since it's not a tetrahedral, it's got that lone pair. That lone pair is going to push those chlorine bonds together. So we got 109 degrees. Now, is this going to be a polar molecule? Phosphorus to chlorine, that's 2.1 minus 3.0, that's 0.9. That's definitely a polar molecule. So, sorry, those are definitely polar bonds. Since there's 3 of them with the 1 lone pair, yes, it's going to be a polar molecule. Okay. Hope that was helpful. If not, please make sure to check in.